So now I am going to talk about the concept of meson and its discovery. So let us start with the concept of nucleus. So nucleus, and it is the core of the atom, and as we know that it consists of two types of particles. One is the proton and another is the neutron. This is the neutral particle and this is the positively charged particle. So as we know that neutral particles can sit together, but this positively charged particle cannot sit together in a very small region, because nucleus is a very small region in which the protons, all the protons will reside. So because these positively charged particles have Coulombic repulsions, so that means what holds all these together means nucleus is not stable, because till now we are having two types of forces. One is the gravitational force, another is the electromagnetic force. And this force is a weaker force and this is the very strong force in comparison to gravitational force. So that means these forces are not sufficient to describe the stability of nucleus. So that means the question arises that what holds the nucleus? Question arises that what holds the nucleus? What holds the nucleus? So in concept of new force was developed. And we call that force as the strong force. Means a new force is existing in nature and people start calling it as a strong force. But we cannot see its effect. We cannot see the effect of strong force in our daily life. As we see for the case of the gravitational force and the electromagnetic force. And this gravitational force and electromagnetic force, these two types of forces are having the infinite range. They have the infinite range. So it was supposed that the range of strong forces is about the size of the nucleus. and we call these forces as the short range forces. We call these forces as the short range forces. Thus, strong forces are short range in nature. Strong forces are short range. Right? Now, the theory of this short range was proposed by Yukawa. The theory of strong force was proposed by Yukawa in 1934. How he got the idea to propose this theory? So, since we know that electron is attracted toward the nucleus, by electric field. And similarly, moon towards the earth, attracted towards the earth by gravitational field. So, keeping these two facts in mind, similarly, proton and neutron are attracted towards one another by some sort of field. And he proposed that this field should be quantized. This field should be quantized. So, keeping these facts in mind, Yukawa proposed that protons and neutrons exchange some sort of particle and whose exchange accounts for the strong force. So Yukawa calculated that the mass of this particle is nearly 300 times that of electron and about 1/6 the mass of proton. And this particle is known as meson. Meson meaning middleweight. Meson means middleweight, means its mass is in between the electron and the proton. And later on in other lectures I will talk about other two terms. One is the lepton and another one is the baryon. So electrons are called lepton, means lightweight, and baryons, protons and neutrons are called baryons, and these are called heavyweight. And another thing that this Yukaba's meson, now known as this Yukaba's meson, is known as muon. Is known as muon. And this was proposed in 1934 by Yukaba, and it was discovered in 1936. It was proposed and discovered. So that means muon is discovered in 1936 by Carl David Anderson. Carl David Anderson. And he was studying. Anderson was studying cosmic radiations. And during their study, that or he observed muons. So let us have a look at a picture. This picture is a very beautiful picture. Yeah. So it's a cosmic ray shower, and 1930 this picture was taken by Carl Anderson, who discovered the muon and the positron. So what he observed that during his, Anderson noticed that particles that curved differently from electron and other known particles when passed through magnetic field. Through magnetic field. Another interesting thing that he did, that Anderson also discovered positron. Anderson also discovered positron in 1932 and also got Nobel Prize in 1936 for the discovery of positron. So that means in 1932 Anderson discovered positron, and in 1936 he discovered muon. So thus a journey has been started to looking inside the nucleus, or a journey of subnuclear physics has been started. Physics has been started. So that's all for today's lecture. Another thing that I also want to mention, the concept of this positron was given by Dirac in 1928. So it will take 4 years to detect this positron, and for muon it will take 2 years. Means concept was developed earlier and they were discovered later on. So that's all for this lecture.